Okay, so we've been looking into setting up transition matrices, and remember we said we use them to predict. So they've collected data, they create these, they know what it's going to be expected, and they create these transition matrices, and then we use that to maybe predict what's happening, in previous weeks or whatever they're talking about. So say remember we had the hot meals, cold meals, so maybe a cafe, and they want to know, all right, how many hot meals are we going to expect on Friday? So they're working ahead to do that. So what we're going to do is we're going to use that, and we're going to use the transition matrix to predict future things, okay? So what we can do is we're going to have this new, we're going to be given what's the original scenario. So say what's going to happen at the start. So say, for example, we said that with that hot, cold, I'll do it here. So we had that hot, cold meals. So say we had hot and cold. Now I'm just making these up. So say this was 0.6. Okay, so I just made them up. Okay, so what we're going to say is we might give you this is the transition matrix for hot and cold meals, but I might say, right, in the beginning there were like, say on day one, say it was Monday, there was 100 people had a hot meal, and say 50 people had a cold meal. Okay, so just say that was at the start. They're saying that's at the start. So what we call that is the initial state matrix. So we would often, what we're going to do is we represent that in a matrix. So I would have a little column matrix here, and that would be hot and cold. And that's what we're saying, and we say it's SO because it's the beginning, 0. And that's called the initial state matrix. So every time we go to the next thing and we work out, that's called the next state. So at the beginning, so you might want to write here, that's this at the beginning, yeah? The scenario, or at the beginning, the numbers, okay? Whoops. The numbers. All right, so that's what that is. So we'll need that. Now this next bit here is called so you'll see they say recurrence relation. So when they write this is a recurrence relation. Now this is simply just a label, okay? So this is a label. So just write that. It's just a label, and it means how you get the next term, how to get the next, or I'll say next state or term, state or term, whatever you want to call it. Okay, so, and then because it says n+1, so that actually, that little n+1, that is subscript. So it just means it's just a little label. So it's just a label. It doesn't mean anything mathematically, okay? Instead of me saying, oh, here's the rule of how you get the next term, I don't need to write that. I can just write that label, okay? Does that make sense? So don't get all, it's nothing to do, it's no equation. It's just a label. And why it says, and so with the n+1 means how I get the next term. And it's this bit so this is using the state before. Okay? So, obviously, if you have S0, you could get the next term by going the transition times S0, and that would give me S1, okay? So that's all that means is, it's just telling us we can keep getting what's happening the next time by going the transition times whatever state matrix we have before. What they're going to do is they're going to say, here's a transition, it follows this recurrence relation, and they'll write this little thing out like that. And all that's telling you is that, okay, I can get the next one timesing it by this transition before. So let's give an example a go. All right, so let's have a look here, and it'll make sense. So it says children at the fair can either go on the Ferris wheel or go on the merry-go-round. At the start, so here they're telling me a start. At the start, there was 140 people went on the Ferris wheel. So you can see here, they're setting up the initial state. We know at the start, because that means at the beginning. And they said 140 at the Ferris, so that's, I know that top number is Ferris. And then they said 80 children go on the merry-go-round. So there's where the 80 is. So they've set up that. So now I know that's F and M that way. And because that means, therefore, this would have to be that way as well. Okay? All right. Now, so that we know that. So they've given me, and now they're saying, use this recurrence relation. So use this formula. So the formula means when SO is the original, okay? So they've given me that down there. And they've told me how I can get the next one is I can use the transition matrix. So this is actually when you're going the transition matrix times the one before, okay? So, all right, so they're just telling me that's the rule you can use. So predict the number of children on the Ferris wheel after one turn. So if you're at after one turn, that means we want state 1. We want S1. And then they also said after 3 turns. So that would be S3 that they want. So let's go first. So if we go to find S1 first, so S1, that would be the next term on, what would be the term before S1 or the state before S1? What would happen before S1? What comes before 1, the number 1? 0. So what I'm going to do is I'm going to times the transition times SO, 0. And they gave me all that. So what I'm going to do is I'm going to pop that transition into my calculator. So I'm going to type that one in, times it, and times it by the original scenario. And what that's going to do is it's going to give me a 2 by 1. So it tells me after one go, it's going to tell me who's at the Ferris wheel and who's at the merry-go-round. I'm just going to pause it, let you guys give it a... I'll pop in. So when you do that, we should be seeing 136 and 84. Okay? So that means after one go, after they've done one go ride, there's now 136 at the Ferris wheel and 84 at the merry-go-round. Now, up the top, how many kids were there in total? How many kids?
40.
No, in total. How many kids in total?
120.
Yep, because if I add these, there's 220, yeah? If you add these up, we're hopefully not losing any kids. So this should always add up to 220 as well, which it does. All right, so that's a good way to check that you haven't typed something wrong or whatever. You should have 220 down there when that adds up. So that's S1. So we found S1. Now they actually want me to get to S3. Well, I'm not going to be able to do that because S3 I'll need the one before, which would be S2. So I'm going to have to find S2 first. So S2 is going to be the transition times the one before, which was S1. So you just type in that same transition again. And you times it by now S1. So S1 is here. So that's what's got to go in there. So it's 136 now and 84. And we end up with an answer. So hopefully if you did this on your calculator, you end up with 134 and 86. And those numbers would add up to 220. Okay, so now we've done that one. So how do you think I'm going to find S3, which is what they wanted me to find? What am I going to do? The transition times what? What's the one before S3? S2, good. So you actually don't have to, if they've written out the transition like that they have in the question, you don't have to actually keep writing it out. You can just write T, but I will put in S2 because that's something I've found. Okay? So to save you a bit of time, you don't need to keep writing it out because we can see what is there. Okay? And then when we do that one, we get S3, we get 133 and 87. Okay, now so it said used to predict how many kids are there after one turn. So here I probably should write a statement that Ferris after one turn was 136 and the Mary was 84, and then down here on the third turn they asked me the same, so Ferris was 133 and the Mary was 87. Okay, so let's have a look. A cafe keeps track of the percentage of people who purchase hot and cold food each day. On the first day, so here they're giving you the initial state matrix. There were 400 hot and 500 cold. So see how they've given you this? So if they don't actually write the state matrix out, you could do that yourself. You could work that out. Okay, and they've given me a transition matrix as well. So here's the transition matrix. And they've told me how I can get the next one is by going the transition times the one before. Okay, so they've told me I can use that recurrence formula there. Okay, so it says the same. It says predict how many people choose hot and cold meals after 1 day or after 3 days. So off I go again. I'm going to have to do this. Now, S1 is going to equal the transition times the one before, which would have been the beginning, SO. So I'm just going to write the transition out once because this is our notes, so in case we go refer to it. And SO is 400 and 500. And we find out after 1 day, if we do this in our calculator, after 1 day we have 560 doing hot meals and 340 doing cold. So that's hot and cold. So we'll say hot 560, cold 340. So remember, we've got to do that because that's what they're asking to get the marks. All right, so now they want me to get to 3 days, but I'm going to have to do S2 first. So I'm going to do S2, and now I'm not going to worry about writing out that whole transition matrix. I'm just going to write it like this. I'm just going to go T, but I am going to put that's S1. S1 in, which was 560 and 340. How many people should we have in total? In the beginning, how many were there? How many did it add up to? How many was 400 plus 500 would be? 900. So just make sure you always got 900 there, and that way you'll know you're not stuffing anything up. So S2, I get 640 and 260. And then now what am I going to do to find S3? What's the formula? I'm going to do S3 equals, what will it be, boys? What do I have to put first? What matrix?
Transition.
Good, transition. And because it's S3, what's the one before?
S2.
Yep, S2. Good. So if we do that, it'll be transition times S2, which was 640, 260. And we end up with 680, 220. That's S3. So I might need to make a statement on day 3 3 days, there was 680 hot and 220 cold. So, boys, so we're finding out, we're using that recurrence relation here. We've been using this. So we've got this recurrence relation, which is here. And they're showing us how to get the next one using the one before. So this is how to get the next one using the one before. Okay, so what we've been doing, we've been using the recurrence. So we've been getting the next one using the one before. So, but what happens is, say like for that, say the meals, the cafe or whatever. What about if I say what's going to happen in a month's time? That would be 30 days. We don't want to keep on going, 30 times to get there. That's going to be too much, isn't it? Yeah. So then this rule here, when they write, this rule here. So this is the rule that we use to find any state at any time, yeah? So this is the rule we use to find any state matrix at any time. So, for an example, how I said, if I wanted to find S state 30, that's like what I just said. What if I wanted to find 30 days later? You can see you've got, what you're doing is you're putting where N is, that's 30 now. So, the rule says to do the transition to the power of N. So because I want 30, I'm going to do that transition to the power of 30. So remember, what do we remember on our calculator? It's that little arrow button, and then you get the square. So it's the power of, and then we're going to times it by, and they would have given us what happens in the beginning, SO. So I'll use that one, and I'll find out what's happening after 30 days. Okay, so let's have a look at this question. It says a study was conducted to investigate the change in population of Geelong and Ballarat due to movement between the two cities. At the start of the study, the population of Geelong and Ballarat were respectively, when they say respectively here, that just means they're mentioning Geelong first because they mentioned Geelong first. So that first number, the 250,000, is Geelong's, and the 100,000 or 110, oh, they've changed that there. So here, can you see that? There's a little fault here. They said 110, but here there's 100,000. So we'll change, we'll change this to 100,000, okay? And is Ballarat. All right, so then they've given me a transition matrix. Okay, and now here, it says in part A, it says using the recurrence rule. So they want me to use the one where you get the next one using the one before. It says find the population after 1 year. So this transition is a year to year. So state 0 is the beginning. State 1 would be 1 year. So let's go do that. So we want state 1. And if you want to put underneath, that's 1 year later. Yeah. We're going to use, it'll be the transition times the one before, which is SO. Okay. So we're going to see this 0.9, 0.15, 0.1 and 0.85, and we're going to times it by the 250,000 and the 100,000. Okay, and then we're going to get what S1, what is happening after 1 year. I get 240,000 up the top and 110,000 down below. So that means in Geelong there was 240,000 after 1 year, and in Ballarat there was 110,000. All right, and then it says using the recurrence rule still, find it after 2 and 3, 3 and 4 years. So you can just keep going. So we're going to say S2 would equal the T times S1. Okay, we're not going to write it all out. You're just going to write the answer there. Sorry, I'm going to rub them out because I want to run out of room. And then, so what would that one be? 240, 110. Okay, so when you keep going, and you would get 232,500 and 117,500. Then I've got to find S3, still going through the recurrence relation. So I have to show this. Because they're asking me to use that, I have to do it. So I've got to just write that little statement out, like the T times S2, and then I can write my answer. So I've got to change that one in. So what was it? 3, 2, 5, and 1175. Okay, so the next one, 228675 and 123,125. Okay, and then we've got to, what do we have to do? 3 and 4. So we've got to get S4. So it'll be the transition times S3, and we're going to pop in our answer. Okay, so now we're going to look at question C. C says using the rule, so now we're going to be using the rule where we can find any term at any time. And they want me to use the rule to find the population of Geelong after 20, 30 and 40 years. So when we've got to find 20 years, that's state 20. So we do the transition to the power of 20 times the SO scenario. So, and if we type all of that in, so what we would be typing is the transition, which we've been doing, to the power, and then times the initial matrix, which was the 25,000 and the 100,000. So when we do that, we get our answer, which, and we're going to round, even though it might have a decimal, we'll round to a whole number because we're talking about population of people. So we're going to get that 210,000 and 139,873. So that's 20. And if we did S30, we would do the transition to the power of 30 this time times SO. So I don't need to type all that out because it is actually stated up here. So I'll go straight to the answer for this one, and we get 210,007 and 13993. So remember, we should have the same amount of people, which is 350,000 as well. And then the last one was S40, which would have been the transition to the power of 40 times the initial one. And with that, we get an answer of 21,000. So 210,000, sorry. And the last one we get is 140,000. Okay. So because they wanted us in the actual question, they want to know what are the prediction for Geelong. So Geelong is the top one. So you'd say this is Geelong. So we'd probably have to write a statement, Geelong equals, and just to show we know which one is Geelong, and Geelong, and Geelong. So the last one. So on question D, when it says, what do you notice about the predicted population? So we can see after the first 20 years, we had a big jump. So what I'm saying is, if you look here, we started with 250,000 in the beginning. After 20 years, we're down to 210. But then after another 20 years, we're still at 2010. So roughly, if we rounded. So what we could say here is, what do you notice? So there was, we could say there was considerable drop. There was a significant drop in the first 20 years. Drop in Geelong's numbers in the first 20 years, and then in the next 20 years, it seems to stay near the 210,000. Okay, and that's what we do see with transitions. Eventually we do hit a number that's not going to change, and it will be known as the steady state. We might do that more next year. Okay, a study of relative growth in duck population at two nesting sites A and B was analysed using matrix method. At the start, there were 8,000 ducks at site A and 10,000 site at B, and they've given the initial state matrix. So this is where we put what happens at originally. So we can see this is A and this is B, site B. So therefore our transition will be A, B, A, B. Okay, so with our questions, it says what is the predicted population after 1, 2 and 3 years. So when we could just do the normal way if you like, but I'm going to do it using the N formula. So what I mean, I'm going to use this one where we do the power trick every time. So if I'm finding S1, it's simply the transition times the SO. So if I do type those numbers in, so this transition times this SO, I get the first one, which was, we get 7,600 at site A, so A and B. Now, if I'm going to do S2, I'm going to use this power trick. So that would be transition to power of 2 times the SO. And when I do that, I end up with 7,400 and 10,600. So that's A and B. And then if I want to do S3, so I can simply just do T to the power 3, but make sure we're just timesing that first matrix every time, the initial one I should say. And we get 7,300 and 10,700 there. Okay, what is predicted population in the site after 20, 30 and 40 years? So S20, so I can keep doing the same, but this time T to the power of 20 times SO, and I end up with, for this one, 7,200 and 10,800. Okay, and then S30, if I pop that one in, I get what I see there is I get the same 7,200 and 10,800. And if I do one more time, this time I'm going to do it at T40, we're going to see that I think we're going to get the same, and we do. We get the same amount again. So what this is telling me is that we eventually, as I said, you do so many transitions, you reach what we call a steady state. And your steady state is when it's not changing. So we can see here, this, when there's no change in the scenarios between A and B, this is what we refer, the blue is known as steady state. And we'll learn a bit more about that next year, I think. But yeah, so we can say, so when they say in the last question D, what do you notice about the population? What will you think happen over beyond the 40 years? I think beyond the 40 years it's going to remain. So, because we noticed there was a big drop there was a change in population in the first 20 years, and then we remain the same. So what do you think will happen beyond the 40 years? So we might write, I think it will remain as 7200 at A and 10800 at B. Okay, so this is just a little summary section because we have learnt a few things in this section. So transition matrix is a T, so we're often referring it with the brackets around it. A state matrix, that just tells us any state in a certain time period. So be careful, sometimes states could be, they could be daily, it could be, we saw one that was yearly, they were talking about yearly, it could be like the rides, if you remember, like first ride, second ride. So that's what a state column is. And we know that the recurrence relation is just when they write it like this, where they give you the initial, the start values in a matrix, and then they write this, we use this recurrence rule, the rule in finding the next state. Finding the next state using the state before. Okay, that's the state before. That's what we knew that meant. And then we had the quick trick way where we could find any state. So we used this to find any state knowing the initial state, which we call SO. Alright, so off we go to 4H.